What is up, ninth graders? Welcome to class 101. Today is SAT Geometry Part 2. I don't know if I told you guys this before. I don't think I told you. But the SAT questions that we use are from a collaboration directly between the College Board, the company who makes the SAT, and Khan Academy, one of the foremost educational nonprofits in the world. The owner of Khan Academy actually went to MIT and Massachusetts Institute of Technology, right? And I think that he has 3 degrees from MIT. So he's a smart guy. MIT is arguably the best engineering university in the world, right up there with Stanford and probably a couple other technology universities. So today we're going to be looking at 5 SAT questions involving volume. But today I'm not going to give you too much help directly in the SAT questions. We will look at those briefly, but we're going to talk about the volume of certain shapes. I hope that you guys know most of these already, but if you don't, that's why we're doing this, to review. The SAT questions are going to be real world examples. I believe every question is involving like a real world situation. Kind of with the exception of number 5, it's a little bit less real world. But the point is that the SAT questions are supposed to be a little bit hard, and I want you guys to spend time thinking about them. Think about this real fast. Anyone can follow instructions, basically anyone. So when you graduate from Minerva and you go to university and then you start applying for jobs, your boss is going to expect you to be a problem solver and expect you to be able to look at an unknown situation, a strange situation that you've never seen before, and be able to solve problems involved with that situation. So the SAT is really testing like who is a better problem solver, right? So I've noticed that like some students, I don't know if it's too much, I don't think too much in 9th grade, but some students will get frustrated when they get a homework assignment and they're like, you didn't tell us exactly how to do this. And I'm like, yeah, the real world doesn't tell you exactly how to solve problems either. And if you think that when you graduate from Minerva, that everyone's going to tell you exactly how to solve the problems, guess what you're going to be doing your whole life? Probably a job you don't like because this world needs problem solvers, okay? Enough ranting, let's talk about these. We're going to talk about the volume of 4 different shapes, okay? Okay, so what's this first shape? It is a cylinder. Okay, cylinder. Cylinder, there it is. And so I want you to think about the volume of a cylinder like this. Think of it as a ton of circles that are stacked on top of each other. That's really what the volume is. Okay, so what's the area of a circle, first of all? Area of a circle is pi, 3.1415, 3.14159265, keeps going. Okay, area of a circle is pi times radius squared. The radius is squared. Okay, so what's the area of a ton of circles stacked on top of each other? That's the volume. Okay, so pi times radius squared times height is the volume of a cylinder. So let me draw the radius here. Radius, boom. And then this side of the cylinder, or this side, we call the height. Height. Okay, so to find the volume of a cylinder, like I said, we can say volume. I'll just go, just to indicate that we're talking about a cylinder. The volume of a cylinder is pi times this length of the radius squared, right? The pi is not squared, only radius, times the height. And that will give you the volume, okay? Some of you maybe are thinking right now, like you're probably not thinking this, but I'll tell you anyway. What are the units for volume? Okay, well, there's a lot of units in the real world that we use to describe volume. And then there's also what we call the SI units, International Standard Units. So I'll tell you, first I'll tell you the SI units. The SI units for volume are meters cubed, okay? meters times meters times meters. And when you're using a formula in physics, all the variables in the formula assume if you're using a formula that involves volume, the formula is set up assuming that you will use meters cubed in the formula. However, in the world, you'll see that gallons are used. Those are units for volume. They're not the SI units, but they are units that are used sometimes. You'll also see liters used. You'll also see milliliters. You'll also see cubic centimeters, cubic inches. The list goes on and on. Okay. So there's the formula for the volume of a cylinder. And, for example, with number 1, they give you these values, the radius and the height, in centimeters. Okay. So you don't need to worry about using the SI units, the meters cubed, for these problems, but just so you know, for the future, meters cubed would be the SI units for volume. Cool. Number 2, second figure, 3-dimensional figure, I should say, is what is that? It is a rectangular prism. Rectangular prism. We'll make it capital R. Rectangular prism. Okay. Now, a rectangular prism does not necessarily have the same 3 dimensions. What I mean by that is like the length and the width and the height could all be different lengths. Okay. So before I tell you the formula, some of you already know it. This is an easy one. Before I tell you the formula, let's identify the 3 dimensions of this figure. Okay. We have the length. We're going to use a cursive L, and then the width, and then the height. We'll use a cursive H. Okay. Why do we use a cursive? Well, I use a cursive L because if I use a normal L, like a lowercase l, it'll look like a 1, right? So that's why I use cursive. So to find the volume of this, think about, first of all, the volume of a rectangle, just like a normal rectangle. What's the area? Sorry, what's the area of a normal rectangle? Well, length times width, right? Or you could say like length times height. But if we have 2 dimensions, the area is length times width. So if you have a ton of rectangles stacked on top of each other, you just do the length times width times height, and that will give you the volume. So we'll go volume of, we'll say, rectangular prism. So V sub RP equals the length times the width times the height. Okay. And once again, it's volume. So the SI units would be meters cubed. But in these problems, they give you centimeters in one case that it involves a rectangular prism. They give you inches in another case, really inches cubed and centimeters cubed. Okay. So you don't need to convert units. You can just use the units they give you. Cool. All right. What do you call a rectangular prism that has all 3 dimensions that are exactly the same? When the length, the width, and the height are exactly the same? Did you say a box? It's not a box. It's a cube. I mean, yeah, a box. I think box is more of an informal term, but we use cube to describe a rectangular prism that has all 3 dimensions the same. Okay. So once again, we have length, width, and height. This is a cursive L. So this is a cube, right? So if you know 1 dimension of a cube, let's say you only know the length, and it is, we'll say 5 centimeters. Then what's the volume? It's 5 times 5 times 5, right? It's 1 dimension cubed, right? So the volume of a cube, we'll say it like that, is equal to, you could say width cubed, or you could say length cubed or height cubed, because length, width, and height are all the same measurement, right? So I'm just going to say length cubed. That's the same as saying length times length times length, right? It's not length plus plus plus. It's length times length times length. So if we have, say it's a 5. 5 times 5 is 25, times 5 is 125, say centimeters cubed, if it's centimeters, okay? Yeah. What else do I need to say about that? Nothing. Okay, one more. This one you guys probably don't know the formula for. This is a what? It's not a pyramid. So let's talk about the shape of this first. We have a triangle. So two of the faces are triangles. And then we have a rectangle on the bottom, rectangle on the side, and another rectangle on the side. So really this is a shape that has like 2 triangles and 3 rectangles that form it. Okay, what do we call that? We call it a triangular prism. Triangular prism. Okay, now I want you guys to think about what was the formula for the area of a triangle. Well, it's 1/2 times base times height, right? It's basically half of the area of a rectangle is the area of a triangle. In the same way, this right here is half of the volume of a rectangular prism. So what's the formula for the volume of a rectangular prism? Length times width and height. So the volume of this bad boy is just half of the volume of that. So it's all this times 1/2. So let's label the dimensions really fast. That's important. We have it doesn't really matter that much what you call length and what you call width, because they're both referring to the dimensions of the rectangle on the bottom. Okay, so we'll be consistent. We kind of called the front dimension here the length, so we'll do the same thing here. Length, and then we kind of called the left kind of we just called the one on the left width, so we'll do the same thing here. Width, length, and width. And then what is the height? The height is the height of that triangle. Okay, so that's the line that goes from the top of the triangle right there and makes a right angle with the bottom. So it's like, let me see if I can get this right. Let me go like this. Wait. Yes. So there's a right angle right there. And so that right there is the height. Okay. So let me write the name of this. Triangular prism. Show me a triangular prism.
According to Wikipedia,
Boom. Just double checking. I wanted to make sure I was not wrong on that. Because I would be so sad if I got to the end of this video and then realized that I told you the wrong name for the shape. That would be really annoying because I'd have to re-record the entire video. No one would think that's funny. Triangular prism. Okay, now we're going to write out the formula for the volume. Volume, we'll say triangular prism. You notice how I make the little curve on the T? Why do I do that? Because in physics, when you're using like a variable t, such as time, the abbreviation for time is often t, if not always t. If you just do a normal t, it looks like plus, and that's really confusing. So we like to use a t with a curve like that. Volume of a triangular prism is equal to 1/2 times the volume of a rectangular prism. 1/2 times length times width times height. Okay. Now let's take a quick glance. 1/2 length times width times height. Yep. Let's take a quick glance at the homework. Again, I purposely don't want to help you too much on these, because if I help you too much, then I'm not letting you think, right? So before we look at these, let me just say that I hope that, as always, that you guys will have an answer for all 5 of these before you watch the solution video, and that you will try with your process. I'm not going to check we're not going to do like the 101A, 101B this time, because that was just way too much grading for me. I tried to do that last week with you guys in 10th grade, and did I do that with 11th grade? I don't remember. With you guys in 10th grade, and I just had way too much grading to do, and I did not sleep enough. And I took like a 2.5-hour nap on Friday afternoon. So I'm just going to check your homework after you're going to send me your homework after you watch the solution video. On Wednesday, you guys are watching this on Tuesday. So on Wednesday is when you'll watch the solution video, and then you'll send me the homework after that. But let's talk about these real fast. So just to clarify, you're not sending me anything tonight, okay? Okay. So first question, they give you a problem involving cylinders. Okay. So be ready to think. Second one, they give you a problem involving your knowledge of rectangular prisms. And notice number 1 and 2 are calculator questions, so you are allowed to use your calculator. And also number 3 is a calculator question. You can see that right there. Again, rectangular prisms involving an aquarium. Number 4 is a no calculator question, and that's involving a die. How do you say dice in Spanish?
In Spanish, you would say dado.
Die is just die is just the singular for dice. Okay. So once again, there's a cube. And number 5, I think the hardest question, although none of them are really that hard, I would say. I think you guys can do all these before the solution video and get them right. Here we have a triangular prism. And yeah, I mean, I don't have much else to say about it. It's just a problem. You have to solve for H in this case using the formula. So yeah, some of these will be harder than others for sure. And what else do I need to tell you? I'm going to put this back on the screen. Boom, that's beautiful right there. Yeah, guys, today is that was the solution video. That was the lecture video for class 101. So have a great rest of your day, and we will see you guys next class.